You're ready now to start and learn about estimation theory, reliability and detection theory, inference theory, machine learning, and so on. Let us have some examples. This is a very simple start point of estimation theory. The more advanced stuff are easy to learn, provided that you learn this one. Suppose that the distribution of a random variable is given to you. This is the simplest case that I could imagine. And we want to find a real value such that this real value is very close to the outcome of your experiment in some average sense. So obviously, depending on how you define the closeness, if you have some topological background, there are different ways to define distance and metric, and also the averaging. Also, you could have it in different ways, but here what we mean by the average is to multiply the distance by the distribution and integrate. So mean square estimation is that, or mean square error estimation means that we consider the difference between the outcome of the experiment and the estimate. So C is the estimate value. We want to this function to be minimal. Obviously, this depends on the output of your experiment, and you don't know the output of experiment. So we want to minimize this function in average. In other words, we want to use the expectation. So this is why we use. So this is the squared error estimation. So this is the squared of this is the error of the estimation. You cannot minimize y of c minus c, because if this c is equal to plus infinity, this is minus infinity. So it's kind of like you have to put either absolute value, okay, or you have to put a factor of 2, or you factor 3, etc., or any other number. So it happens that if you put 2 here, the resulting of our analysis, when you go further down, becomes a bit easier to calculate, or it will have a unique solution, because you're minimizing a function, and this function will have some optimal value, some minimum. So in many examples, the squared here will simplify your life. So the mean square error estimation, or criterion, is defined by the average of these error. So we want to minimize this. So obviously, if you calculate the expected value of a random variable minus a constant number to the power of 2, this is mean. So this is mean of squared of, and this is error. So if you minimize this function, which is called mean square error, the method is called minimum mean square error estimation method. This is the simplest case, but it can become a bit more complicated when you have multiple random variables involved. You know some of them, you don't know some of them. Here, there is one random variable, we don't know it. So it's the simplest case, and it's ideal to start with. So this function is basically equal to the value that this guy takes on times the PDF of whatever we don't know, and then you integrate. So we want to minimize this one. Now, if you calculate derivative of this one with respect to c, whatever it is, you set it equal to 0, solve it, then you get a unique solution, and then C optimal is the solution of this equation. And it's called minimum mean square error estimator of y. And in this example, it will be very straightforward. So if you do that, derivative of, because if you calculate d to dc, okay, derivative from outside of the integral can go inside, because this C is these boundaries are not a function of C. They can go inside. This is not depending on C. Derivative of this one becomes -2. And if you equate it equal to 0, you can eliminate this constant, and then you could write this one. This is integral from -infinity to +infinity of y f y of y dy, and then minus integral of c f y of y dy, and from -infinity to +infinity shall be equal to 0. So if the difference of two numbers is equal to 0, they shall be equal to each other. This c is constant, can take it out of the integral, and this guy should be equal to 1, so this is equal to c. So the optimal mean square error estimator is equal to this integral. So basically, C optimal becomes equal to this integral, which is the expected value of y. So the optimal minimum mean square error estimator of y is equal to the expected value of y. So this is simply the expected value of y. In this example is very straightforward.